Module 11, problem set 2. Here we're asked to come up with the Lewis diagram for boron trifluoride. Let's go through our 5-step algorithm here. To begin, we'll find the number of valence electrons. Boron is in group 3. Fluorine, a halogen, in group 7. We're going to have a total of 24 valence electrons. We'll identify the central element. Here that's going to be boron. We'll attach the adjacent elements, fluorine, fluorine, and fluorine. We'll give everything an octet that needs an octet here. Fluorine is going to require its octet. Using lone pairs on those adjacent atoms. We've now given the fluorine its required octet. We notice the boron does not have a share in 8 valence electrons. It has a share in only 6. But recall that boron was one of the exceptions to the octet rule. This is still a favorable configuration of atoms and electrons. Boron does not need an octet. So it is okay with the 6. Each of the fluorines has their complement of 8. We now need to check to see that we have used the required number of valence electrons. We have 8 times 3 for 24. Indeed, we had 24 available. This is the correct Lewis diagram for boron trifluoride. All right, let's do one more. And here we will incorporate a noble gas. So let's try krypton difluoride. All right, we'll find our number of valence electrons. Krypton, a noble gas in group 8. It's going to contribute 8 valence electrons. 2 times the 7. Here we're going to have a total of 22 valence electrons. Krypton will be our central element. We'll attach those fluorines. We'll give everything an octet that needs an octet. Krypton will get its octet. Fluorine and fluorine each have an octet. So from the standpoint of the octet rule, everything looks happy here. We now check to see how many valence electrons we've used. 8, 16, 18, 20. We've used 20 valence electrons. We've satisfied the octet rule, but recognize we had 22 available. We need to use all 22. Every time this case arises, we continue to add lone pairs of electrons to that central element until the required number has been used. This now represents the correct Lewis diagram for krypton difluoride.